All right, guys, welcome back. Hopefully that wasn't too bad for you. There's some interesting algebra in this one, so this should be kind of fun. Again, we're looking at 16.3, proving that something is a rhombus, and we're looking at the practice problems on page 232. We're going to kind of look at 10 through 15. Number 10 basically asks, is it possible for a rectangle to be a rhombus? I feel like they were giving us a little bit of a foreshadowing, if you will, because that's what the next section is about, but we like to call those squares, okay? Remember, a square is a rectangle, and a square has 4 congruent sides, so it's a rhombus as well. A square is kind of like our magic shape. So yes, 10, the answer is yes, and it would be a square, okay? Number 11, 12, and 13, very similar to the last couple of sections as far as when we're making shapes, given 3 points, trying to find another shape. So what I did was I shortcutted this a little bit, and given the points they gave me, what I need to keep in mind is I'm proving rhombus, so I need all my sides to be the same length. So I need to pick my points such that the 2 lines that I draw have to be identical length, and then when I draw my new lines, they're going to be the same length as well. So this one ends up being basically kind of a slanted rhombus. And if you notice the change right here, is x is plus 5 and y is plus 5, okay? We go over 5 and up 5. So we're going to do the same thing here, plus 5 and plus 5. To our original point, negative 9, negative 7. Negative 9 plus 5 is going to be negative 4. And negative 7 plus 5 is going to be negative 2. So that is going to be kind of our magical answer there for number 11. Number 12. Number 12, I wanted to kind of take a minute to show you something because I think some of you are probably going to make a very simple mistake here. I don't think it's a bad mistake, but it's just being a little careless. If you drew your rhombus such that it did this and then came over here, the problem with that is that these are not congruent lengths. This length does not equal this length, and that's not okay. All right? If you do distance formula, you'll see what I'm talking about. So that is not okay. This is one of those no's. That's not allowed. Which means really what we have here is our line is drawn this way. And so our fourth point is actually going to be over here. And so if we look at the change that happened here, we went back 3 and up 1. So from this point, if we're at negative 1 comma negative 1, and we go back 3 and up 1, we're going to get to negative 4 comma 0, and that's going to be our answer for number 12. All right. Number 13, just looking at the change, it's a plus 2 and a minus 3 coming from this point. So if this point is 1, 1, we're going to add 2 and we're going to subtract 3. So 1 plus 2 is 3, comma 1 minus 3 is negative 2, and that's going to be the coordinate of our fourth point. And again, you can go back and kind of watch through that again. Very similar to when we did the rectangles. 14. 14 is what I was talking about, like some serious algebra here. 14 actually gives us 2 values or 2 expressions for x, one of which has an x squared though. There are several ways to do this. You could graph it, you could try to factor, all that kind of stuff. I'm old school. I really like quadratic formula. I like quadratic formula because I don't have to stress about whether or not it factors, whether or not it's a whole number, any of that stuff. So, quadratic formula, what I've got here is 2x squared equals 3x plus 5. I move the 3x plus 5 over. When I do that, both signs are going to change. So this becomes 2x squared minus 3x minus 5 equals 0. This is my a value. My a is 2. So my little a is 2. My little b is negative 3. And my little c is negative 5. I'm going to plug that into the quadratic formula. In case you don't remember, quadratic formula says if, and we'll actually write out the whole thing because I think it's good for you, ax squared plus bx plus c equals 0, then x equals negative b plus or minus the square root of b squared minus 4ac over 2a. If that seemed unfamiliar to you, you need to go study that because it is an amazing piece of mathematics. So we're going to take this formula and we're going to plug it in right here. This is mostly algebra 1. I'm just getting excited because I think it's fun. So if you're stressing about it a little bit, this is algebra 1. But anyway, we plug in our values. Remember, a was 2, b was negative 3, c is negative 5. When I plug those in, do some simplification. Square root of 49 is 7, so I get 3 plus or minus 7 over 4. Keep in mind there's no such thing as a negative distance. And so we don't want to plug in a negative x, so I don't worry about the minus 7. And I get 3 plus 7 is 10 over 4. 10 over 4 is 2.5. Okay, hopefully that makes sense. So x is 2.5 for A. For B, not worth our time. That's a very simple one. You're just showing that the sides are equal, so you solve for x here. For 15, I'm not going to work 15, and I'll tell you why. It's the exact same as 11, 12, and 13. All they're asking you to do on top of that is distance formula, and I think you're okay with that. So find the fourth coordinate, do your distance formula. You can either do distance formula 4 times, or you can remember that it's a rhombus and do it once and multiply by 4. That's up to you guys. Thanks for coming, and I'll see you in 16.4.